So let's go for the some of the preparations continuation. This is the another method in the third method. So the first two methods we have seen, simple methods and the special methods. The third method onwards, these are all used only for argon, that is aromatic compounds. Aromatic compounds we are going to prepare here. In the third method specifically, by introducing a carbonyl group into benzene. So we are not going to prepare the benzene, but take benzene and get this group into that, so that the carbonyl compounds are prepared. In that, we have one good method, that is Friedel-Crafts. This is a well known reaction in the benzene chapter. We have seen Friedel-Crafts acylation. We have alkylation, but in that method alkyl benzenes will come. So let us take a benzene. In this method, a carboxylic acid chloride is taken, treated in presence of anhydrous aluminum chloride. However, the scientists observed that aluminum chloride easy to prepare anhydrous form, because when you heat it, it sublimes and then immediately you will get some anhydrous aluminum chloride formation in the test tube mouth. So the taking or preparation of aluminum chloride easy, so they said, but later identified you can take iron chloride, chromium, any Lewis acid can be used here, so that the Cl minus is taken away by the aluminum chloride. The RCO plus is actually the attacking species. This will go and attack on the benzene, and finally you will get a acyl containing benzene. So you get ketones. So the method is useful for the aromatic and aliphatic, or the other side you can take that is also aromatic, then both the sides aromatic type of ketones will be. But the aldehydes, it is not, the method is not suitable. The Friedel and Crafts accepted that you cannot take formic acid chloride, because this is the unstable one, so that you cannot prepare a benzaldehyde. So aldehydes means the aromatic aldehyde is benzaldehyde. So the benzaldehyde, provided if this compound reagent is available, we could have prepared, but they said this is very unstable, so you cannot use the formyl chloride, and then preparation of aldehydes, aromatic aldehydes, is difficult or not possible by this method. But however, the problem was thoroughly understood by a group of scientists called Gatterman and Koch. These two scientists they observed the problem and then suggested a method. Yes, this formic acid chloride is unstable, but you need not to take this compound. You can take carbon monoxide and HCl, and in presence of aluminum chloride. In fact, these two compounds will react, and immediately what comes is nothing but the formic acid chloride, which is the unstable one in fact. But the unstable one will have a high reactivity. So the one benefit is there, more the unstable reagent, more reactive, such reagent will attack fastly. So that is what happened here. So instantly, that is, this is called in situ. In situ means in the situation, if that reagent is unstable, let us prepare that reagent temporarily in the reaction. The moment it comes, it will attack. The same mechanism, aluminum chloride will hold the Cl minus and generate, say, formyl carbocation, which will attack and will enable to prepare the then aldehyde, that to aromatic aldehyde, that is benzaldehyde, can be prepared. This is what they have shown, they have successfully explained this method. What they accepted, it is not possible, but Gatterman Koch proved that benzaldehyde can be prepared by this method. So, the credit goes to the scientists Gatterman and Koch. They understood the problem of this unstable compound and they prepared in the reaction, then seen that it is attacked and then benzaldehyde. The same type of reaction can also be prepared by another reaction given by the again Gatterman. The Gatterman alone also he gave one more reaction. The benzene, instead of this carbon monoxide and HCl, HCN is taken, treated with the HCl. These two will join and you will get a formimino-chloride like this. 1 H will be there on the night. This is also very unstable compound, and from here also the same catalyst, that is anhydrous aluminum chloride, is used, and that will take away the Cl. And however, you won't get directly the benzaldehyde, you will get this formimino containing benzene will come. So, the benzene with a carbon with double bond NH, you can call this compound as a formimino benzene is formed. This is the compound from which if you hydrolyze it, acidic medium or basic medium, the C double bond N hydrolyzes, 2 hydrogens go that side, 2 OHs eliminate water, you will get the benzaldehyde. So, this method is also almost similar to this one, and wherein instead of carbon monoxide HCN is used, and HCl is common and anhydrous aluminum chloride is common, but the direct there you won't get benzaldehyde. The formimino benzene will hydrolyzes to give the benzaldehyde. This is called Gatterman formylation. Formaldehyde is coming, this is also formaldehyde coming. So, therefore, formylation. This is also formylation. The last two methods are restricted methods to for only benzaldehyde. This is common to the different types of the alkyls, methyl, ethyl, propyl, and even aromatic also. So, this is a common method for different types of the aromatic aliphatic and aromatic aromatic, two sides aromatic also you can prepare. But these two methods are restricted for only benzaldehyde, where this method enables not able to prepare the benzaldehyde. Now, these methods are providing the preparation of the method for the benzaldehyde. So, let us go for the another method, fourth method. This is also for only aromatic, that too specifically it is a formaldehyde introduction. So, therefore, called formylation. Formylation of phenol. So, starting material is phenol, on which we are introducing a aldehyde, formaldehyde group. Actually, on benzene formylation is slightly difficult, but on phenol it is quite easy. So, therefore, there are around 3-4 reactions are there. The first reaction is again popularly known Reamer-Tiemann reaction. Reamer-Tiemann reaction. In the chloroform topic, we have taken this reaction. In this reaction, phenol is taken and treated with the chloroform and KOH. Boiled for some time, as we have seen first a CCl2, which is called dichlorocarbene, and the phenol in the basic medium exists as a phenoxide, which is a more activated benzene than the ordinary benzene, isn't it? So, when phenol is taken, phenol itself shows a plasma effect and the orthopara will become rich. But in the basic medium, phenoxide comes, which is more reactive than even ordinary phenol. So, the order goes like this. Phenoxide means it is basic medium, which is more reactive than ordinary phenol, than the ordinary, that is benzene. So, then benzene formylation or electrophilic substitution in phenol is easy. Then phenol in basic medium much more easy, because phenoxide is a strong activating group and it is a plus M group. So, therefore, it is now here we are using that concept phenol in basic medium, phenoxide comes, again it is ortho para directing. So, therefore, the CCl2 is the attacking species which can attack at ortho and para. So, what you will get is phenol with aldehyde at ortho plus its para isomer, that is the aldehyde group also may go to the para. So, mixture comes, as we have seen in the remetimer also. I said the mixture can be separable not by the ordinary distillation, but by with the steam. When you send the steam, the ortho isomer, because of the intermolecular hydrogen bonding, it has slightly lesser boiling point, therefore, it can be distilled over the para isomer. So, therefore, the ortho isomer is steam volatile. Therefore, it can be a separatable from the mixture of these two isomers. Similar reactions we have, basic skeleton reaction is same, phenol gives the salicylaldehyde plus its para isomer, but the reagents I will tell. There is another reaction called Wills-Meyer reaction. Wills-Meyer reaction. In this reaction, the skeleton is same, but the reagent I am mentioning, the reagent is a formic acid, formamide, formic acid amide with the 2 methyls. So, it is shortly known as a DMF. DMF stands for the dimethyl formamide, dimethyl form, it is a wonderful solvent also. The DMF is the reagent now here. In addition to this DMF, we are using another catalyst called POCl3, phosphorus oxychloride is the catalyst here, and here the mechanism is this polarizes into O minus C plus, the C plus will attack on the phenol, and then when O minus comes back, this group will go, takes the hydrogen of the phenol, this will become into that is N with NH with the, that is dimethyl amine is formed. This group settles in the compound. So, phenol when you take, again you will get the salicylaldehyde and its para isomer. Only the reagent is different. Chloroform KOH heating is remetimer reaction. DMF and POCl3 is known as Wills-Meyer reaction. Similarly, there is one more reaction called Duff reaction. The first two is very popular reactions, but Duff reaction is not that popular. The reagent, again I am telling only the reagent. There is one reagent called 6 CH2s are there N 4 times. It is known as hexamethylene tetramine. In presence of solvents like glycerol heating, this partly decomposes to formaldehyde, and the formaldehyde is attacking, same product is forming. That is, starting material is again phenol. When treated with this one, you are getting the first compound is ortho member and the para, both salicylaldehyde and the para compound is going to form. There is one more reaction which has no name, but the reagent I will tell. Reagent is formic acid ester of the ethyl, ethyl formate it is. In presence of basic medium like NaOH or KOH violet, the C double bond O polarizes into minus and plus, the plus will attack. When O minus comes, this OET will go, finally the aldehyde group settles. So, again starting material is phenol, you will get salicylaldehyde and para. So, in all these 4 reactions, starting material is phenol giving the salicylaldehyde. The first member has a specific name called what? Salicylaldehyde. The second member has no common name, you have to go for the saying formilated phenol or hydroxy benzaldehyde, para hydroxy benzaldehyde or paraformyl phenol, either way it is okay. So, in all these 4 reactions, first 3 are name reactions. The order of importance also, the remetimer is coming several times in the IIT examination, very fewly, that is less importance for the Wills-Meyer. Then the Duff reaction, then there is no name, but this is also very simple technology. On phenol, when you add ethyl formate in basic medium, this formyl group is introduced into the phenol at ortho position and the para position. So, all these four methods are applicable to aromatic compounds preparation, the two specifically converting phenol into salicylaldehyde and its para isomer restricted methods. So, let us see the one more method, that is fifth method. Even this is again for only aromatic aldehydes and ketones. In this method, we are in fact converting an R group into a carbonyl group, that is either by halogenating and then hydrolyzing or by oxidizing the alkyl group, we prepare a carbonyl group, but there is an already alkyl group is there in the benzene, that group I convert into carbonyl. So, therefore, in this method again there is a few methods which are very important. First method is known as Itard reaction, is a name reaction. Itard reaction. In this reaction, a suitable example, let us take one methyl group containing benzene known as toluene, So, in this reaction, the methyl group we are oxidizing into the aldehyde group. So, the reagent is also very specific, chromyl CrO2C. This is called chromyl chloride. The chromyl chloride can be generated from the any chlorine containing salt like KCl or NaCl. Add solid potassium dichromate and constant sulfuric acid. The chromyl chloride is released as a gaseous compound that is treated with the toluene. It actually shows a compound like this. Out of the 3 hydrogens, the 2 hydrogens are chromylated, that is the H of this one and the Cl is going out. So, this group comes twice in fact. Out of the 3 hydrogens, 2 get substituted with this chromylation, then this compound is hydrolyzed. So, first you treat it with the chromyl chloride, then this compound is formed. Second step will be the hydrolysis. In presence of the H3O plus, these 2 groups will go, 2 OHs will come, that will be converted into the benzol. So, net reaction is toluene is converted to benzaldehyde. Methyl benzene has got a common name toluene. So, pronounce it as toluene, but it is nothing but the toluene or methyl benzene is oxidized. It's an oxidation method, oxidation of methyl benzene. However, under the similar conditions, you can take a long chain also like ethyl benzene and butyl benzene. It is said that the reaction leads to give the CH2CHO. In fact, there is some ambiguity in this reaction. Some books also saying this benzylic hydrogens get oxidized, but some book says that it is the last carbon. That is, if you take ethyl benzene, this type of CH2CHO is prepared. However, it is clear that the hydrogens are hyperconjugable, undergoes a chromylation followed by hydrolysis will give this aldehyde. This is a name reaction called Itard reaction. Is name reaction is one point, and the reagent is also unique chromyl chloride. Usage of this unique reagent in this reaction is again one of the speciality. Let us go to the another method, second method. That is also a name reaction called a Sommelier reaction. In this reaction, a benzene containing CH2Cl, this is called a benzyl chloride. Benzyl chloride may be prepared from toluene by monochlorination using the chlorine UV light, side chain halogenation you can. and preferentially you will get the 1 chlorine containing toluene, that is called benzyl chloride. This benzyl chloride is treated first with the CH2 6 times and N 4 times. This is called hexamethylene tetramine, commonly known as hexamine also. Hexamethylene tetramine is commonly known as hexamine, or it has a commercial application. It is used as a diuretic medicine under the trade name urotropin. So, this is prepared from the formaldehyde and ammonia combination. Heating formaldehyde ammonia condenses to give the hexamethylene tetramine. It has one commercial application also. Nitration of this hexamine leads to give the RDX, that is a research developed an explosive compound, very powerful gum type of the explosive compound. But here this hexamethylene tetramine is liberating the required reagent. First it attacks on this compound, a salt is formed which an acidic medium undergoes a sort of rearrangement and then gives the benzaldehyde. It is a two-step reaction. First, make reaction with this hexamethylene tetramine, you will get a benzene CH2, then CH2 6 times N4, a salt is formed, followed by hydrolysis rearranges to give this aldehyde. It is a name reaction called Somerset reaction. Similarly, you can go for the one more method, which is a hydrolysis method, hydrolysis of benzol chloride. That is, already if 2 Cls are there, the method already we have verified in the aliphatic compounds also. If 1,1, that is gem type of halide systems are there, we can go for the hydrolysis in basic medium, aqueous NaOH, boil for some time. The OH replaces, you will get 2 Cls are replaced by 2 OHs. However, 2 OHs eliminate water, that gives the aldehyde group. So, hydrolysis of benzol type, this is called benzol chloride or benzol dichlorotoluene, you can say benzol chloride. Di may be neglected and said directly benzol chloride, benzyl chloride, benzol chloride, one more Cl if it is there, benzo trichloride, that on hydrolysis will give benzoic acid. So, benzol chloride on hydrolysis will give the this type of this one. If 3 halogens are there, you can convert into first benzoic acid. Benzoic acid make a calcium salt, calcium benzoate. Then pyrolysis in presence of calcium formate, you will get the benzaldehyde. Or you can take benzoic acid, acid chloride, that is benzoyl chloride. Benzoyl chloride adding Lindlar's catalyst and hydrogen gas, that is reduced through the resonance reduction. So, the acids can be converted to aldehyde using the calcium salt and calcium formate. Pyrolysis will get aldehyde, or you can go for the benzoyl chloride, that is benzoyl chloride undergoes resonance reduction to give the benzaldehyde. That is also one method. So, a methyl group may be oxidized, monochloromethyl can be oxidized, dichloromethyl can be oxidized, trichloromethyl through acid to calcium salt and reduction, or acid to acid chloride and then reduction will give the benzaldehyde. So, all these methods are by converting an alkyl group into the carbonyl, we can achieve a carbonyl group containing aromatic compound. This is the last method.